So, in fact, before I even do this, let me just put this slide up here. Again, reminder, in order to write a linear equation, there are two things that we need to know. What are those two things we need to know to write a linear equation? What's one of them? Yeah.
At least know 1 point.
At least 1 point. Point on the line. What's the other thing that I need to know? Who else forgot it? Besides the guy who doesn't do his homework but still knows everything, and if he did his homework would probably have A pluses. Yeah. What's the other thing we need to know? Okay, go ahead. The slope. Now, there are several ways we can find the slope of the line. Okay? Several ways we can find the slope. What are some ways to find the slope? What?
Never mind.
Okay. I didn't hear what you said. Because sacrificial. No, sacrificing a squirrel to the god of slopes does not reveal a slope to you. I'm sorry. Nuts? Ah, I see what you did there.
What did you even mean to do that?
I see what you did there.
What?
Yeah. Sure. If we have 2 points, we can use the slope formula. Which is y2 minus y1 over x2 minus x1. Right? What's another way we could possibly find the slope of a line? Well, I'll tell you one. We could be given the slope. That's nice when they do that. Here's the slope. Okay, that's great. Okay? And by the way, if they say it's a vertical line or a horizontal line, that's giving us the slope too. Vertical lines have undefined slope. Horizontal lines have slope of 0. What's another way we can find the slope? Yeah. Okay, that's the point slope formula for a line. But the third way we can find slope, and this is always the one that gets a little trickier, is to know the slope of a parallel or perpendicular line. To find the slope of a parallel or perpendicular line. Okay, in that case the slopes will be equal if it's a parallel line, or know the slope of a perpendicular line, in which case the slopes are negative reciprocals. What was weird? Okay? So if they're negative reciprocals, that's the other way of knowing the slope. So basically 4 different ways we can get the slope of the line. By calculating it, because we know 2 points. If we're given the slope, which is nice. By knowing the slope of a parallel line, in which case the slopes will be equal, or by knowing the slope of a perpendicular line, in which case the slopes will be negative reciprocals. Okay? So usually we find the slope first, then the point. Once we know those 2 things, hold on. There we go. Once we know those 2 things, then step 3 comes in, then we need to write the equation. Okay? And most commonly, what is easiest to do for that, in most cases, is using point slope. That's probably what ends up being the simplest way, because it uses a point, okay? x1, y1 is the point, m is the slope. And we already know at this point a point and the slope, don't we? Since we already know the point and the slope, point-slope formula is the easiest way to do it. Because we need to know a point and a slope. I can use slope-intercept and solve for the y-intercept and go through that whole process if you want. It's longer, it's a lot more algebra, it's a lot more prone to error. Point-slope is very straightforward and easier. So even if you didn't learn this way in Algebra 1, it's a way I'm kind of recommending in geometry, although you are welcome to go back and use slope-intercept if you want, if that's what you're familiar and comfortable with. I would recommend, however, working on point-slope just because it's something you're going to use again in Algebra 2. You're going to see it again in Algebra 2. And again, it is a little bit faster and a little easier once you get used to this format. The big thing to remember is the x and the y in point-slope stay just x and y. And the x1 and the y1 are what we substitute in for. We put numbers in for x1 and y1. But x and y just stay x and y. We don't have to do multiple substitutions. That's a nice thing. All right. One last note. Okay. If the slope equals 0, the equation is just y equals m, y equals b, whatever the y-intercept is. Okay? Or for that matter, y equals y1. Because whatever that is, that's a coordinate of a point. Because you already know a point, you know if the slope is 0, it's just y equals y1, whatever y is, because there's no slope. 0 times x is 0. If the slope is undefined, the equation is x equals x1, whatever the x-coordinate of the point I know is. So an undefined slope is an x equals equation. These are things I'm hoping that you've copied down into your own notes because you should have this information. If you're concerned about not having step-by-step notes or instructions, here they are. And hopefully you've been writing these down as we go. Because what becomes very difficult for me and for other math teachers who say, okay, well, what do you need to know in order to find the right an equation of the line? You say, I don't know. And you say, well, what did your teacher tell you? He didn't tell anything. Or she didn't tell me anything. Sure we did. I just told you exactly what you need to know to find the equation of a line and how to do it. These are the steps that you need to follow. And a couple of special cases even. So let's look at this in practice. I'm going to use a different equation. I'm going to use y equals. I'm going to use a different formula here. So this is the y equals mx plus b method that's written out. I'll leave it up here, but I'm going to use the other method as well. Given a slope and a point, find the equation of the line. If I give you the slope and I give you a point, it's really straightforward. Y minus y1 equals m parentheses x minus x1. This is the slope-intercept method where we solve for b and then have to back substitute, which is a little bit extra work. The point-slope method I'll show you is quite straightforward. Again, we did this yesterday. What is y1? What is y1 with this information? Is it the negative 3/4, the 8, or the 1? Which of those numbers would be the y1? You guys are staring at it like it's in Greek. Okay, I've got a slope and I've got a point. What are the, by 8, 1, which one represents the x-coordinate, which one represents the y-coordinate when I give you the coordinates 8, 1? 8 is the x-coordinate, 1 is the y-coordinate. y1 that we're getting, and these are really x1, y1. Those are the points we're given, okay? That's x1, y1. So which number represents y1? 1 does. Yes. Thank you. Y minus 1 equals m. Which number is represented by m. Negative 3/4. X minus fill in the blank. Which one is the x one? 8. It's almost slope-intercept form to begin with. That's the nice thing about point slope. It's really close. Then we do two things. I distribute. And negative 3/4 times negative 8 is plus 6. And then we simply solve for y. So y equals negative 3/4 x plus 7. One step, distribute, add or subtract to both sides, done. No resubstitution, no anything. Unlike here, substitute, multiply, add to both sides, find b, resubstitute, extra steps. Y equals mx plus b takes extra steps. It's not wrong, it just is longer. Yes? Undefined? Sure. Okay. Point is, give me any point. 6, 2. Okay, 6, 2 is my point, and the slope is undefined. When the slope is undefined, the equation is always just x equals, and whatever the x-coordinate of a point that I'm given is. The point is 6, 2. Which is the x-coordinate? 6. That's it. There's no formula. There's no y equals mx plus b. There's no point slope. We don't use any of that because the slope is undefined. It's always x equals whatever the x-coordinate of the point is when it's undefined slope. If the slope was 0, if it's the same point, we could go through the whole thing, but it's really simpler than that. It's just y equals whatever the y-coordinate of my point is. In this case, 2. So what if I did undefined? So with that, let's see if we got that. I'm going to do point negative 7, negative 1, and slope is undefined. What's the equation going to be? X equals negative 7, the x-coordinate. Undefined is always an x equals. Undefined is weird, okay? Just think of it that way. Normally, my equation is y equals, right? My equation is almost always y equals, but undefined is a weird slope, which means we can't use normal stuff. It's got to be weird, which is x equals instead of y equals. Okay? Slope of 0 is fine, so it's still y equals. It's just y equals y coordinate. If it was slope of 0, it would be y equals what? Negative 1, the y coordinate. All right? So that's kind of what's going on with the undefined 0 slope. You don't have to put them through a big formula. You don't have to. That's the beauty of people always think 0 and undefined are the hardest problems to work with, but really they're the easiest ones because you don't have big formulas. You don't have to use y equals y and you do distributing and all this other stuff. It's just x equals or y equals. And that's what I put up here. If the slope is undefined, it's just x equals whatever my x-coordinate is. If the slope is 0, it's y equals whatever my y-coordinate is. That's why I put that on that page. All right? And again, folks, what I'm not seeing here is I'm not seeing people writing this down at all. I'm seeing people stare at it, watch me do it, and go, oh, yeah, makes sense. And I ask you a question about it right after you do it. You go, yeah, makes sense, got it. And they get home, they're like going, no clue how to do this. Because you're not actively participating in learning right now. And that's kind of what we got to work on with you guys sometimes, is being actively participating. I see people with their books closed staring at what I'm doing. That's not active learning. It's not effective learning. That's not a good learning style. But I can't do that for you. You got to get out a pencil, you got to get out a piece of paper and a notebook, and you got to write stuff down. Jot down some examples. Jot down key points like, wow, if the slope equals 0, the slope is undefined. Those are quick shortcuts I can know. Then when you don't get it, when you're doing it again, you can kind of look back and see what you wrote instead of just try to remember what I said. Makes a big difference. So seriously, folks, get out a piece of paper, jot down some examples, make your own notes on the sidelines about what things mean if you want to change the wording so that you understand it better. But this is not a sit and get situation. You need to actively involve yourself. All right? It really makes a difference. It's going to help you do better. Graphing the line. Did anybody have trouble graphing lines, or were you pretty good with that part of it? If you're given the equation, can you graph the line? You can start, you start at the y-intercept. Y equals 1/2 x minus 3. We start at the y-intercept, which is -3. We know the 1/2 indicates the slope, which is rise over run, and that's starting at the y-intercept to get the next point up 1/2. Okay? It does not indicate the point 1, 2 is on the line at all. I still get people who make that mistake. They mistake slope with coordinates of points. Slope is a ratio, coordinates are different. I had several people on the last quiz, when I asked you to calculate the slope, gave me coordinates instead of a slope. Slope is a ratio. Coordinates are in parentheses with the comma between. They are not the same thing. They just aren't. And once I get enough points drawn, usually at least 3 points drawn, label their coordinates, and then I connect the dots to draw the line, including there are arrows here, but they're a little small because of the way it's set up. Arrows on the end to indicate it's a line. It goes on forever. It is not, if I say draw the line and all you draw is this portion from here to here, but you stop with no indication beyond that, have you drawn a line? You drew a segment. Okay? It's not a line. Line goes beyond, arrows goes on forever. That's what we're working on now, is lines, not segments. Whoops. Lost my dots. Didn't mean to do that. There we go. Plotting the intercepts. Not even going to bother with that one because I'm not so concerned about it. So let's take a look at the homework from last night. Let's take a look at that worksheet. Oh, I think I put them all back in the back desk. I kind of cleaned out things up last night. Where's the line day one? Here we go. Here stays. And really, I just took a quick peek, and I already ran off the quiz. I took another quick peek at the quiz, and seriously, this is what these worksheets are all little warm-ups for the quiz. There's nothing on there there's nothing that we haven't already covered that's on that quiz. Let's take a look at that. Now, 1 through 4 were almost gimmies, because they gave you the slope. They didn't just give you a slope and a point, they gave you a slope and the intercept. So when we give you the slope and the intercept, so y-intercept at -5, I mean, that's as easy as it gets. Slope, intercept. That's y equals mx plus b form. Obviously, we aren't going to use anything other than y equals mx plus b when they give us the slope and the intercept. So are there any questions on 1 through 4? Because they gave us a slope and the intercept. All we had to do is plug those numbers in. We didn't have to calculate anything. We didn't have to do any algebra at all. If you're given the slope and the intercept, that's like a freebie. I guess another way to find the slope that I didn't mention on that previous slide, I missed one. Another way to find the slope is to count boxes, I guess. If you're given a graph of the slope, if you're given a graph of the line. So, for number 5, the y-intercept is at -5. That's easy to see. But we need to find the slope of that line. What is the slope? Well, the next point that it really crosses at in number 5 is 1, -1, right? So that's up 1, 2, 3, 4, and right 1. So the slope is what of that line? What is the slope of the line in number 5? If we go up 4 boxes and over 1 box, what is the slope of that line? 4 over 1. So the equation is simply y equals 4x minus 5, because I know the slope and the intercept. And again, that's using slope-intercept form. Guys, when you don't answer, I don't know if you honestly don't know how to find the slope on that line, or if you just don't want to answer. That's why I need you to answer questions, because if you don't answer, the only assumption I can go on is that you don't know how to find the slope when you have 2 points, and I have to go back. And then people get frustrated because I know how to do that. Well, then let me know that by answering the question. Where's the y-intercept for number 6? 1, okay? And boy, finding another point on that line, the next point doesn't come until 2, -4, does it? So what was the slope on that line? -5. Number 6? Oh no, the slope is -5 over 2. Okay, I'm sorry. I thought you were giving me the point. My bad. Totally. Okay. Yeah, the slope is down 5 over 2. So
Y equals -5/2.
plus 1, because it's positive 1. Now, common mistake people make is they get the slope, they get the intercept, but they forget to put x in here. Remember, x is the variable that always goes there. So -5 over 2 is the slope. It's slope times x. You want to take your device away from your face there? Thank you. Let's put that stuff away for now, folks. Seven and 8 were similar. And again, the answers are given. Is there any problems with 7 or 8? Then let's start looking into 9 and 10. 9, 10, 11, 12, they give you a point and the slope of a line. When they give you a point and a slope, our best bet and yes, that is another little formula that we have to memorize. And one of the things I've seen in this year from people is a very strong unwillingness to spend time memorizing things. People just don't seem willing to do that. No, I don't want to memorize it. And that really hurts. If you don't memorize it, it's going to be hard. You got to know the formula. And again, I can write it down 100 times. We can do, whatever. But in the end, it's up to you to memorize it. So for number 9, remembering that when we do this, we're going to substitute in for y1, m, and x1. Those are the numbers we're going to substitute in for. The just plain x and the just plain y are going to stay just plain x and just plain y. So y minus, what number is going to go in for y1 for number 9? You need your worksheet out for this. Need your head up. Owen.
Question.
Number 9.
So what's the correction I graph?
What number of those numbers that are given there is going to be put in for y1? -2. Which number are we going to put in for m? 2/5, parentheses x minus, and what's going to go for x1? -5. I'm going to change my minus negatives to plus positives. Then I've got 2 steps once I've got my number substituted in. Distribute. Y plus 2 is 2/5 x plus 2/5 times 5, which is just 2. Finally, second step, get rid of this number by the y, so -2 from both sides, and you go y equals 2/5 x plus 0. Now, you could put the plus 0 down, or you could leave the plus 0 off because it makes a little difference, but I can tell now my y-intercept is at 0 and my slope is 2/5. So if I need to graph that line, we could do it. Question? Sure. Number 11, our point was 3, -1, and the slope is -2/3. So again, putting it in, y minus, what is going to be y minus what? Y minus 2/3. Is that what y1 is?
No.
-1 is y1. 2/3 is the slope, which is m. -2/3. Yes, that's -2/3. Okay? You got to know which number is what. Here. The x1 and the y1 come from the coordinates of the point. The m comes from the slope. Equals m. What is m? -2/3. Then we put our parentheses in, x minus the x coordinate of my point, which is 3. Change that to plus positive. What's the first step now to solve this? Distribute, right? So y plus 1 equals -2/3 x. -2/3 times -3 is plus 2. And then move this away from this side, so -1. -2/3 x plus 1. So a little bit of algebra there. The slope was undefined, so it's just going to be x equals the x coordinate of the point, which is -2. How about number 12? There's a 0 in there. That can kind of mess people up. Okay. My point is 4, 0, slope is 1/2. -1/2. Y minus what?
Second number.
I'm sorry. 0. Okay. Equals m. What's m going to be? X minus 4. So y minus 0 is just y equals -1/2 x. Distributing negative times negative is a positive. Half of 4 is 2. There's my equation. We're done. One step that time. The 0 is not a problem. It works right out. (13 through 16) goes back to our decision again. How do we find the slope? Well, now we aren't given the slope anymore, so we have to use a different method finding the slope. In this case, it's using the slope formula because we're given 2 points. All right? So for 13, it's 3, 5, and 0, negative 5. All right, folks, you need to keep your heads up, paying attention. All right? So what's the first thing we're going to do? We're going to find I know point on the line. That's easy. I've got 2 points. I've got more than enough information there. What I don't have is a slope. So we have to find no, not y-intercept.
Find B. Or MX.
To find the slope of the line, yes. Okay? We have to start by finding the slope of the line. 1 point and the slope. We have points. We need to find the slope. Since I'm not given the slope, we have to calculate the slope, in this case using the slope formula. Because I'm given 2 points, that's how we calculate slope. So that's y2 minus y1 over x2 minus x1. Negative 5 minus 5 over 0 minus 3. This is what we did last unit. Okay. Negative 10 over negative 3, which would be positive 10/3, right?
Yeah.
Okay, because negative over negative, they cancel out. Now, I'm kind of assuming you know how to find slope, because we've spent quite a bit of time doing that. And now once we have that, now we're good. We go right to our y minus y1. Now, if you're observant here, you'll notice that the 0, negative 5 is your y-intercept. And that would be, so we could just do y equals 10/3 x minus 5 and we'd be done. Okay? And that's great. Most people aren't going to catch that. So let's go ahead and use our formula, and you'll see that it comes out anyway. Y minus y1. Now, I do have to pick a point. I'm given 2 points. I do have to make a decision. Which point am I going to use? I'm going to choose this one, because it's got a 0 in it, and zeros make things easier. So y minus negative 5 equals m x minus 0. Well, it's y plus 5 is 10/3 x, and 10/3 times 0 is 0, so that's easy. And now we just subtract 5 from each side. And there's my equation, the slope-intercept form. Yes?
So, like on the test, since you want to push your more words, instead of doing that final step, we just like, if we already know that that's...
You could just point to this and say y-intercept. Just that indicates to me that you recognize it. And then that's showing your work in my mind. All right? Let's do one more like this, and let's move on to some of the other ones that we're going to see today with linear equations, parallel and perpendicular lines. Which one do you want? Let's do 14. 2, negative 4, and 3, negative 5. Okay, again, I have a point. We have to find the slope. So y2 minus y1 over x2 minus x1. Negative 5 plus 4 is negative 1. 3 minus 2 is 1, so that slope is negative 1. Then I pick a point. Which one do you want to use? The 2, negative 4, the 3, negative 5? It doesn't matter which one. Okay. Just pick it. So y minus y1, which would be negative 4, equals m x minus x1, which is 2. So y plus 4 equals negative 1x plus 2. And now we just subtract 1 from each side. Plus 1. And there's my equation. Yes?
Which one's M again?
M is the slope. Slope is right here. This is for number 14. Did I copy something down wrong?
Yeah, it's supposed to be y plus 4, not plus 1. You see, I went
Oh, yes, I did copy it down wrong. You're right. You're right. You're right, so this would be plus, that'd be minus 4 then. So that'd be minus 4. So it'd be minus 2 in the end. Sorry. You're right. I just copied it wrong. I didn't carry down the right number. My bad. And that's that happens. But again, notice when I showed my work, we were quickly able to identify where the mistake was. Oh, I copied a number down wrong. If that was on a test, how many points off, if you did that, how many points off do you think you'd have on a 3-point problem? 2. 1. For a mistake like that, 1, because you're showing all your work and all you did was copy a number wrong. Now, what if we did, because we still have a couple minutes, be patient, okay? Today, what we're throwing in the mix is the parallel and perpendicular line. So what if it says parallel to y equals 2/3 x minus 7 through the point -1, -5. Okay? The slope, we have the point, y minus -5 equals m, x minus -1. But what is the slope? One of the ways you can find the slope is by knowing the slope of a parallel or perpendicular line. I'm given the equation of a line. We do not need to graph it. We should not graph it. All we need to know is the slope of this line. What is the slope of this line?
2/3.
And since it has to be parallel, what is the slope of this line going to have to be?
2/3.
The same. Okay? So y plus 5 equals 2/3 x plus 2/3. And now I have to subtract 5, but that's okay. So what you're going to be doing today is we're throwing in this case, going back to our notes, we're throwing in these two situations today. Find the slope of a parallel line or find the slope of a perpendicular line. And we do that from the equation of the line. So you're going to see several problems today where it says parallel to this or perpendicular to that. Now I'm always giving you the equation in slope-intercept form, so it should be easy to find the slope of the line. But it's the same technique. Once you find the point in the slope, we keep using the same technique over and over again. It's just that sometimes you have to be a little bit of a detective to figure out what the slope is going to be or how we're going to find the slope of that particular line. Again, yes. Show your work, please. Answers are on the back. I think I just gave an extra to the other road, didn't I? No? Let's take that back. Sorry. I thought I gave 5. There we go. Keep working on it. This is the major focus of this test. Tomorrow we're going to review it again. And then Friday is the benchmark. Yeah. Which one? I'm sorry? I should have that in the testing center later this afternoon.
Okay.